Hello everyone and welcome to this new video which is about how to construct and draw a topographic profile. Before we start, it would be very useful to you if you haven't watched the rest videos on leveling to watch them because they are related to this one. In fact, there are 4 videos about leveling and contouring, 3 videos on leveling. The first one, introduction to leveling, and the second one, how to book your measurements and do the calculations using the height of collimation method, and the third one was about how to check the accuracy of your work. And also there was a video on how to draw contour lines, because today we are going to start from this point. After you learned how to draw contour lines, now you have contour lines like these, for example. And then the aim of today's session is to let you know how to construct and to draw a topographic profile. The topographic profile illustrates the topography that's intersected by a vertical plane. Okay, for example here, if I would like to construct a topographical profile along this line, for example, you can imagine that there is a vertical plane here, vertical plane to intersect these two mountains vertically, and then you are going to draw the topographic profile resulting from this intersection. It would be, in this case, as we can see here, something like that. You will have the first mountain and then the second one, something like that. But we are going to learn how to draw this topographic profile accurately. So here from the contour lines, for example, we have a topographic profile A prime, and then you will learn how to construct a topographic profile from the contour lines directly. So if you have a topographic map, mostly there would be kind of contour lines on it as a reference for elevations. And for your project, if you need to construct a topographic profile, you can use the contour lines on your map to draw and construct this topographic profile, and this is what you are going to learn. So let's say, guys, that we have this example. We have a map with a contour lines like these that you can see here, and then our aim to construct a topographic profile along line A prime, this line. And this topographic profile would be very useful for us to show the changes in the shape of the land along the line of the profile, along this line. So we would be able to see any change in the topography or in the shape of the land along this line. So how to draw this topographic profile? In fact, there are a lot of methods to draw the topographic profile from contour lines, and here I'm going to present one of them. First, you need a piece of paper, and it's preferred to be a graph paper to help you in the drawing later. So you need a piece of paper, and then you are going to fold this piece of paper in half like this, as you can see here. And then we are going to lay the edge of this paper along the line of the profile. So the edge of the graph paper, this edge, we are going to lay this edge along the line of our profile like this. So this is our paper here, guys, folded in half, as you can see here, and then we lay this along the topographic profile that you are going to construct. In this case, we named this to be A prime. As you can see here from the topography that we have these contour lines, like the elevation of each contour line is given The elevation of this contour line is 100 meters, 200 meters, 300 meters, 400 meters, 500 meters, 600 meters. And don't forget that, for example, this line here, when you go with it, is the same of this one. Okay, so this is a whole line. Okay, here in this case we have a contour line like this. All the points on this line have the elevation of 600. For this one, all the points on this one have the elevation of 500, and so on. So what I would like to mention here, that this line, for example, when we start from here, have the elevation of 200, and then when we go with it like this, okay, until this point, this is the same line, so the elevation of this one is 200 because it is the same line. And for this one, its elevation would be 300 because this is this contour line. Yeah, so for the contour lines, as you know, all the points on the same line have the same elevation. So now you know that, guys. Now what we are going to do is we are going to record the positions and elevations of contours that intersect the paper. Okay, this is our paper. Okay, let's see how to do that. This is the paper, of course. And let's start from here, from point A towards A prime. So first, this is contour line of 100 intersects the edge of the paper here. So I will just put a mark here, and then I will write the elevation of this contour line. In this case it is 100. Yeah, this is the contour line 100. Now I will move to the next intersection point here on the edge of my paper, guys. This is the intersection point between the contour line of 200 and the edge of my paper. I will write here 200, and so on. So this contour line intersects with the paper here. This is 300, and this one here 400, and this one here 500, and this one here 600, and this one here, what is this one? Yeah, think about it. It is really 600, the same line. So this is the same line. Look at the line. This is all of the points on this line are 600, yeah, and all of the points on this line are 500. So this one would be 500, and this one 400, 300, as you can see here. So if you follow this, it is 300, which is the same over here. Yeah, and here we have 200 and then 100. So now, after completing locating all the intersection points with the contour lines on the edge of the paper, okay, as we have done here, we have transferred all the elevations of all of the intersection points between the contour lines and then the profile, along the profile that we are interested in. In this case, our profile is AA prime. So now the next step is we are going to unfold our paper. It's folded in half, as you know, and now we are going to unfold our paper like this. Now we have the first axis here, which is the distance along the profile line AA prime in meters. So this is what we have done in the previous step. So, and then we unfolded the paper like this. This is the rest of the paper, the other half of the paper, okay? And now we are going to draw a vertical axis like this. So now we have a vertical axis, guys. For the elevations, we need to pick a suitable scale. For the vertical axis, this one. Let's say that I'm going to use a scale of 1 to 10,000, for example, which means each 1 centimeter represents 10,000 centimeters, or in other words, each 1 centimeter represents 100 meters. Yeah, so this is our scale for the vertical axis or the elevation axis, this one. It would be good to exaggerate the vertical axis so that you can see the changes in the topography in a better way. For the horizontal axis, for the distance axis, it is the same scale that you've got from your map. For the vertical one, you can pick a scale that suits the elevations that you have. So now, because I use this kind of scale, my scale is 1 to 10,000, or each 1 centimeter represents 100 meters. I have the range of the topography that I dealt with from 100 meter to 600 meters, as you know. So here, the first 1 centimeter would be, this is the first 100 meters, and here 200 meters, and here 300 meters, 400, and then 500 meters, and finally 600 meters, because the contour lines that we dealt with ranges from 100 to 600, as you remember. Now we are going to draw some dots to mention the changes in the elevation. For example, this is for the elevation of 100 meters. This is 100 meters, so I'm going to locate a dot here for this one. Okay, for the 200 meters, I have this line for the 200 meters, and this is the second dot, and so on for 300 meters. For 400 meters, just the intersection point between the elevation and along the distance. So this is the elevation here along the distance, just we are locating the changes in topography. Now for 500 meters, the same. This is the line along the AA prime line, and this is the line along the vertical axis. I will draw a dot or little cross for 600 meters. This is the intersection point. And now the next intersection point would be 600 meters as well, which is this one on the same line for this one, because it is 600 meters, and next one would be 500 meters along the same line here for 500 meters. This one 400 meters, 300 meters, 200 meters, and finally this is the intersection point for 100 meters. Now once you've done that, you have to draw now a smooth line to join all of these points. I will start from here, for example, going down, trying to make it as smooth as I can, and then on the other side, on the top here. So now let's go down from the top, trying to pass through each one of these points. Of course, I'm drawing this on a tablet, so it's not easy to be accurate, but I try to be as accurate as I can. It would be better, as I mentioned, to do this on a graph paper. Everything would be clear in front of you. The intersection points would be easier to locate. So by doing that, guys, we have completed drawing the topographic profile AA prime for this case, for this set of contour lines, using a specific scale for the elevation axis, which is 1 to 10,000 in this case, which means each 1 centimeter here along this axis is 100 meter on the ground. Okay, I tried to draw this on a separate piece of paper, just wanted to share this with you. So this is the same drawing that I have done, using the same scale for the elevation, which is 1 to 10,000. Okay, and here of course we have distance along line AA prime in meters. and the elevation in meters. Now you learned how to draw a topographic profile. No matter now what kind of contour lines that you have, you can apply the same process to construct a topographic profile that you need. Thank you very much for listening. I hope that was useful to you guys, and see you in the next video. Bye now.